All right, I know what you're thinking. You're thinking, what about 2 to the aleph naught? Wouldn't there be the same potential problem with 2 to the aleph naught? After all, if I'm validating or attempting to validate the continuum hypothesis, I need to address, well, what about 0 times c? Well, let's focus here on the board. Well, what about 2 to the aleph naught? Doesn't it have the same problem? Well, notice I have 2 times 2 times 2 times 2 aleph naught to an aleph naught place value here would be equal to 2 to the aleph naught, and I could do the same thing hypothetically with the zeros, 0 times 0 times 0 times 0, countably infinite number of times arriving at 0. Well, wouldn't I be canceling the 2 every time? Well, notice a particular property of infinity, that infinity would be of the same level of countability as, let's say, 2 times itself. Now we're referring to aleph naught, okay? Aleph naught would be of the same level of countability as 2 times aleph naught. So, hypothetically up here, I could have, well, 2 to the aleph naught place values, okay? 2 times 2 times 2 times 2, not 2 to the aleph naught, excuse me, 2 times aleph naught, pardon me. 2 multiplied by aleph naught. Okay, so I could have 2 times 2 times 2 times 2, 2 times aleph naught times, getting me 2 to the aleph naught. It's a little confusing, but I bear with me. In other words, we have a countable infinity here, but that could just as easily be 2 times aleph naught. It would be the same thing as aleph naught. So therefore, if our 0 were to cancel out our 2 each time, in that case we would still have aleph naught, 2 to the aleph naught left over. Because up here we would have 2 times aleph naught place values, and here we would have aleph naught place values, but the 0 canceling out the 2 would still get us 2 to the aleph naught. Now suppose we had it the other way around, where we had aleph naught place values for our 2's, and then we had 2 times aleph naught place values for our 0's. Well, our 0's would then cancel out our 2's, and yet we would have a countable infinity of 0's left over, in which case our 0 times 2 to the aleph naught would be 0. So wait, either our 0 times 2 to the aleph naught is 2 to the aleph naught, or our 0 times 2 to the aleph naught is 0. Well, that's undefined. Okay, so there is no rational answer for 0 times 2 to the aleph naught. And so we don't have the same paradox that we would have with some level of infinity between 0 and c. Between aleph naught and c. Okay, so now let's discuss case 2, where, and this is maybe more complicated and more of an abstract argument, where we don't have, we can't really construct our aleph 1 on the basis of 2 times 2 times 2 a certain number of times, or 2 to a certain power getting us aleph 1. Okay, and that would be the objection that most of the mathematicians would make. Well, I would argue that I will agree that our greater than deals with levels of countability and not necessarily something numerical. However, I believe my personal take on that would be that it's too abstract. If we're going to talk about the continuum hypothesis, we are positing the existence of a level of countability. A level of countability between aleph naught and 2 to the aleph naught. Well, if we're talking about a greater than and a lesser than, in other words, 2 to the aleph naught is greater than aleph 1, is greater than, which in turn is greater than aleph naught, it has to have some kind of mathematical consistency to it. I'm not suggesting that what is constructed is what exists, but what I am suggesting is I don't believe that we can proceed on the basis of what exists would contradict what is constructed. And if we're going to talk about levels of countability, I believe that we have to have some kind of rigor in constructing that. All right, we've come to the end of what could be a very explosive series, or what could just be a byword. I have no idea how this is going to go over. But this is my request of this audience. First of all, I appreciate you bearing with me. I know that's my first YouTube video. It's going to look a little bit, it's my very first YouTube video. I'm definitely an amateur. I take full responsibility for the cut and all the different problems. But I appreciate you bearing with me, and my request of you is very simple. A lot of mathematicians will take the side of something that they believe in, and they believe in very fervently. But I'm asking you to step outside of the role of being a mathematician and take the role of a defense attorney or a debater. In other words, I'm asking the majority of you who will disagree with the continuum hypothesis to step outside of your disagreement and give the minority opinion at least the dignity of constructing a potential argument that you could see that might uphold it. In other words, taking this, and I know it's a little bit amateurish. I'm not a professional mathematician. I do not have a PhD in mathematics. I do not have the background that the majority of people who would doubt the continuum hypothesis have. The majority of people who doubt the continuum hypothesis have a very advanced level of science and mathematical education. But can one of you at least act as a defense attorney in the tradition of Clarence, Darrow, or in the tradition of the great defenders of freedom of thought in the past, and essentially construct an argument that you can see that would validate the continuum hypothesis? Take this and run with it. That's what I'm asking you to do. Be my defense attorney. Defend me against the charges that I have violated Paul Cohen's argument somehow, and I do not believe that I have. But the predominant weight of academic opinion is against what I'm saying. So let's at least have some fairness here and consider a minority opinion. So I'm calling upon you to not just be a mathematician, but be a philosopher and be a debater, and let's have some kind of conversation here. So one of you out there, help me out, and help me for the sake of freedom of thought. Thank you.